Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Zul Hakimi Hakim bin Zaini dan nombor kad matrik saya ialah AA200922. Okay, next I will tell about introduction pulverized fuel ash. Pulverized fuel ash, also known as fly ash or flue ash, is a coal combustion product that is composed of the particulates, fine particles of burnt fuel that are driven out of coal fire boilers together with the flue gas. In a modern coal-fired power plants, fly ash is generally captured by electrostatic precipitators or other particles filtration equipment before the flue gas reach the chimneys. The minor constituent of fly ash depends upon the specific coal bed composition but may include one or more of the following elements or compounds found in trace concentrations up to hundreds ppm. Such example arsenic, beryllium, boron, cadmium, chromium, hexavalent, chromium, cobalt, lead, manganese, mercury, molybdenum, selenium, strontium, thallium and vanadium, along with very small concentration of dioxin and PAH compounds. It also has unburned carbon, Helisonia, Gordon, Alfredo, Alfaro, Guillermo, Garcia, Zimena, Ulao, Claudi, 2003, coal blend combustion, link between unburned carbon in fly ash and mercurial composition. For this report, we had investigated that pulverized fuel ash PFA is very important and had many advantages than disadvantages for the human life, and it also very attractive for use in many construction.
Assalamualaikum warahmatullahi wabarakatuh, sir. I hope you have a good day. My name is Muhammad Hafiz bin Azhari. Today, I would like to discuss about material property. Our material property apply two property. First one is physical or mechanical property, and the second one is chemical property. Physical or mechanical property. First, fly ash is cleaner than the Portland cement and lime. This is because this tiny glass pair enhance the fluidity and workability to fresh a concrete. Second, fly ash consists size particles that are typically spherical, which is the scale is between 10 and 100 microns. Third, full ash is physically relatively stable but also slightly relative chemically. In the typical low intensity and the together, which is chemical feature that improve cement binding. It has widely used as a small group. Okay, second, chemical properties. Chemical properties full ash is mostly made from the silicon, aluminum and calcium oxide, which is the amount of the magnesium, potassium, sodium, titanium and sulfur is also lower. Second, full ash, which is produced from the hydrocarbon combustion, contains primarily reduces of the mineral. This is made the full ash grade for the two class, which is class C and class F. This is happen because depending on the chemical composition of the mixture in the concrete. Class C full ash is typically extract from the subterraneous core, and it is mostly made up from the aluminium, glass, calcium, core, tricalcium, aluminium, and the fill lime. And the last one, class F, where is the full ash typically come from the bituminous and extrusion core, and are the composed mostly of the aluminium silicate glass, which also available called malachite and magnetite. This class F has a length of have a less than 10% of the calcium oxide or low calcium in the fuel ash. Okay, that's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Faris Safidin Mirosli. My matrix number is AA200232. Okay, so today I'm going to explain to you the process and procedure of manufacturing pulverized fuel ash. Based on figure 1, pulverized fuel ash is manufactured by electric and steam generation plants fired from coal. Coal is usually pulverized and blown with air into the combustion chamber of the boiler, where it ignites instantly, creating heat and forming a molten mineral residue. Boiler tubes remove heat from the boiler, cooling flue gas and hardening and forming ash from the molten mineral residue. Coarse ash particles, referred to as bottom ash or slag, fall to the bottom of the combustion chamber, while the flue gas suspend the small ash particles, referred to as fly ash. Fly ash is removed by particulate pollution control systems such as electrostatic precipitators or filter fabric baghouses before exhausting flue gas. So next is the standard testing for the pulverized fuel ash PFA. Fly ash consists mostly of silicon oxides, iron and calcium aluminium oxides. Magnesium, sodium, titanium, potassium and sulfur are also present to a lesser extent. Based on its chemical composition, fuel ash is graded as either Class C or Class F ash when used as a mineral mixture in concrete. The chemical composition of Class C and Class F is described by the American Association of State Highway Transportation Officials, or AASHTO. So next is the process of material application of pulverized fuel ash, PFA. Proprietary lightweight aggregates, rounded pellets of PFA are sintered and subsequently graded into various particle size and as aggregate in concrete. So, originally, the spherical shape of fuel ash creates a ball-bearing effect in the mix, improving workability without increasing water requirements. Also, fuel ash improves the pump ability of concrete by making it more cohesive and less prone to segregation and resistant to corrosion of concrete, reinforcement, attack from alkali silica reaction and sulfate attack, acid and salt attack. Generally, fuel ash provides increased concrete strength gain for a longer period than mixed with Portland cement only. Fuel ash reacts chemically with calcium hydroxide during hydration process, forming calcium silicate hydrate and calcium aluminate, reducing the risk of leaching, calcium hydroxide and concrete's permeability. That's all, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazri bin Mazihan, AA200177. I will explain about discussion of PFA. First, the benefit for sustainable construction. The benefit of PFA concrete are improved long-term performance in terms of strength, improve durability through reduction in mixing water, improve cohesion and workability for a given water content, improve surface finish, improve resistance to sulfate attack, reduce heat of hydration, reduce shrink and cracking, reduce bleeding, resistant to alkali silica reaction. Fly ash can be cost-effective substitute for Portland cement in many markets. Fly ash is also recognized as an environmentally friendly material because it is byproduct and has low embodied energy. The measure of how much energy is consumed in producing and shipping a building material. By contrast, Portland cement has a very high embodied energy because its production requires a great deal of heat. Fly ash requires less water than Portland cement and is easier to use in cool weather. Other benefits include produce various set times, cool weather resistance, height strength gain depending on use, can be used as the admixture, considered a non-sharing material, produces dense concrete with a smooth surface and sharp detail, great workability, reduce crack problem, permeability and bleeding, reduce heat of hydration, allow for a lower water semen ratio for similar slump when compared to non-fly ash mixes, and last, reduce CO2 emissions. Okay, the disadvantage of PFA is smaller builders and housing contractors may not be familiar with fly ash product, which can have different properties depending on where and how it was obtained. Additionally, fly ash application may face resistance from traditional builders due to its tendency of efflorescence, along with concerns about freeze or thaw performance. Other concerns about using fly ash in concrete include slower strength gain, seasonal limitation, increased need for air entraining admixtures, increase of site scaling produced by higher proportion of fly ash. Okay, lastly is our future recommendation is optimizing fly ash content in concrete. The properties of fresh concrete and the mechanical properties and durability of hardened concrete are strongly influenced by the incorporation of the fly ash into the mixture. The extent to which fly ash affect these properties is dependent not only on the level and the composition of the fly ash, but also on other parameters including the composition and proportion of the other ingredient in the concrete mixture, the type and size of the concrete component, the exposure condition during and after placement, and construction practice. Clearly, there is no one replacement level best suit for all application.
On the report results, the objective of the research stated above has been successfully achieved. We can conclude that pulverized fuel ash (PFA) had many benefits to construction, especially in concrete. The research results supported the use of 20% pulverized fuel ash extracted from Kapar Energy Ventures Sdn Bhd Malaysia for making soil cement bricks that have the appropriate mechanical and chemical properties to be used as a load-bearing PFA soil cement interlocking bricks. The average water absorption of the 13% PFA brick is 20.65%, and based on the BS 3921, there is no limitation for the load-bearing brick. Therefore, interlocking bricks that contain up to 13% PFA may be used for construction. The initial rate of suction of the 13% PFA brick is 6.46 kg per min, and based on the BS 3921, there is no limitation for the load-bearing brick. Therefore, interlocking bricks that contain up to 13% PFA may be used for construction. Soil cement interlocking brick containing up to 20% PFA shows a unit optimum compressive strength of 9.86 MPa. The 3-layer and 5-layer brick prism test for 20% PFA soil cement interlocking have the average maximum stress of 2.76 MPa and 3.20 MPa respectively. However, pulverized fuel ash also has disadvantage, but it does not mean Malaysian industry do not use it as material in construction because of its benefit is lot than is its disadvantage.